Hello, everyone, and welcome back to the Unleashing DePIN podcast. My name is Tyler. I'm your host, and I'm very excited for our next guest we get to have. We are joined by Mike from GEODNET. You are one of the projects where I've heard so many good things about you from so many independent sources. They're like, you got to talk to Mike, you got to talk to GEODNET. And so I have been eagerly awaiting this conversation. But Mike, welcome to the podcast. How you doing?
I'm doing great. Thanks for having me, Tyler.
Absolutely. This is gonna be fun. I know we're gonna talk about a bunch of different things with respect to GeoDNet, some hardware, some products. It's gonna be great. But maybe to start the conversation off, can you just give a little bit of background and info for folks about who you are, kind of what you've been doing, how you got into this space, and we'll kick it off from there.
So my background is electrical engineering, computer science. I studied at UC Berkeley. I got into the field of sensors, and my master's thesis was actually on virtual reality using head tracking, developing head tracking technology, which was 20 plus years ago. So a little ahead of its time, but I've been in the field of sensors and navigation my whole career. I started a company right out of college called Crossbow Technology, which was a pioneer in the development of GPS plus inertial measurement units for things like drone navigation. So early days of autonomy, built that into products that were used in autopilots for farm tractors and ground robots. So really been working on navigation guidance, localization technologies for autonomy and robotics my whole career. I got into Web3 because one of the canonical problems in robotic control is accurate positioning. And GPS is an incredibly low cost, easy to use sensor for positioning things, but it's just not accurate enough for robotics. But if you're able to correct GPS for the errors that it has from things like space weather and get accuracy through a technique called real-time kinematics, you can get accuracy that's centimeter grade. So, positioning within really the size of a thimble. And that then is a super powerful technique for robotics, self-driving, drones, and these types of applications. And we look, that technology prior to GeoDNet was very, very expensive. So it's being used in things like construction and survey for a while, but at incredibly high price points and not easy to access either. So not everywhere had this type of coverage, this RTK signal coverage. So we really were inspired by the practices of Helium and the IoT network, how quickly they were able to scale that up, and saw, could we build out a global RTK network using the same kind of principles? And really, we were early enough to DePIN that it wasn't even yet called DePIN. And we did see really positive indications in our market that this technique would work and that customers would accept and thrive on a more decentralized approach to RTK networks, and hence GeoDNet was born.
That's incredible. So, and you guys have been around since 2022 timeframe, is that right?
That's right. Our first node started going out in March 2022.
Okay, that's exciting. So obviously you've been in this sort of location sensor space for quite some time. It's definitely been up your alley since university, it sounds like. Where did you first see a specific customer segment or demand segment that you said there's an opportunity to really deliver? I mean, you talk about the kind of the growing market within these different, call it agriculture, robotics within that agriculture space, but where did you initially think, hey, I think people will pay for this because of X? Is that something you can talk about?
Yeah, I mean, I think that we saw that the cost of these high precision GPS chips was really going to plummet. And so the applications could proliferate. Having been, I mean, I've really spent my whole career in this field of autonomy. So to me, it's always been there. It's really been a question of when's the iPhone moment when the technology comes together where there's enough AI, there's enough compute, and really in particular to autonomy, there's a big push for sensor technology. You need really good sensing technology to make these systems work. When are all the things that are technologies going to come together so that you can have mass market affordable robotics? And that moment is now. And RTK based localization is one of the key ingredients to make that happen, as is some of the developments in other sensors, such as computer vision and LiDAR, and also the compute and the AI that goes all around that to do perception. But now is that moment. And you're going to see over the next 5 years, I think robotic devices become like iPhone, iPad type things where everybody has a couple in their home. And GeoDNet's going to be the fuel to make that happen.
Yeah, that's incredible. So I was talking to our friend Brad, who does the DePIN Connection YouTube channel last week, And he was telling me he was in a Discord channel with somebody who had set up one of your sensors, and he was at a construction site or something. And the guy, he walked up to the construction manager and said, "Hey, what are you using for some measurement within their site?" He pointed at the node and he said, "I'm using that thing right there." I didn't even know what it was. And the guy said, "That's my device." And it was for GeoDNet. I thought that was such an incredible, just interesting story, if you will. What are some of the specific use cases that people might be familiar with that would leverage the GeoDNet network? Is that something you can share?
Yeah, absolutely. So that example is a classic survey application. And survey, which is, where you see the construction guys out working typically with a pole in hand, making field measurements. That is the field that kind of invented this technology. And that is a real application that lots of guys in our community do. So we have, through some of our Web 2 resellers and just through now reputation, we have actually quite a lot of surveyors that use the network every day. And it's a very precise job surveying. This is where not only do you need the precision, the centimeter precision, but it's to an absolute standard. So it's not like, oh, I need relative accuracy. I need absolute position on the ground truth to centimeter level. And if you don't get it right, it can cause really big problems downstream. You can ultimately build the building in the wrong place, so to speak. So that's a very classic use case. Another very classic use case that's in mass production today, and GeoDNet is really helping drive a broader adoption of it, is precision agriculture. And precision agriculture now, if you buy a new tractor from John Deere, AGCO, or Case New Holland, any of the major brands, it's already got a RTK-equipped GNSS receiver. And it can do things like automated driving and map out your land, so you're really running the tractor over the same B lines every time. They call them A-B lines because you don't want to run over your plants, right? And it's a big machine, fairly hard to control, and the distances between the rows is very tight. So that technology is quite mature and it's in mass production. The challenge again is the cost. It's very expensive stuff. Subscriptions to these services are so expensive that actually in the US, only a third of farmers actually use that capability that's on their tractor. And that's where
Really?
GeoDNet comes in. And that's why folks like the USDA are excited about what we're doing, because if there's broad adoption of precision farming, the other 2/3 of farmers in the United States that aren't using it yet, that turns out to have very positive environmental impact. It also ultimately, once you start using the tech, lowers the recurring costs, the input costs for the farmers. So I think those two applications, sort of machine control, construction, and farming, are the classic applications for high precision geospatial, and GeoDNet's doing extremely well in both of those markets. The new markets that we think we're going to really enable and are working towards a very dominant position in is technology like drones and small consumer robots, and ultimately even regular old consumer devices like wearables and phones. These are applications that traditionally have not been able to afford RTK, but it's becoming affordable now. And you see there's rumors out. So DJI makes about 800,000 RTK equipped drones every year. We're very popular amongst various DJI dealers, and aftermarket products and services to resell the RTK network from GeoDNet has become quite a popular thing. There's also newer drones in the works that will be much closer to the consumer price point from some of the biggest manufacturers. There's rumors out there on the internet, you can Google them, that these basically consumer drones will start to support RTK. Why is RTK support from drones? Is a lot of it has to do with making the drone really flyable and more adverse conditions. If there's any wind and you want to do a hold, keep the camera on target, you want to have the auto land work really well, you want to do drone in a box, you want to do drone delivery, all these types of things that where precision makes a difference, and it takes a lot of the workload off the pilot to automate those functions. So I think we're going to see these drones and robots just become very consumer friendly, and you're going to see everybody basically own one.
Yeah. The first thing I thought of as you were talking about that was, the Amazon delivery systems. Sounds like there might be a interesting intersection there for using this network, because I imagine they care a lot about the precision and being able to navigate some of those challenges that you just discussed, right?
100%. 100%. Drone delivery, drone in a box, drone survey, drone mapping, even basic drone photography, all benefit directly from RTK. When you take a drone up, if you have RTK and you put it in a hold, it will hold the position of the drone within basically a golf ball. And if you don't have RTK, it can't do that because it's going to get blown around by the winds. Yeah, sure, the pilot can kind of try to hold it steady, but just that basic function of I want to put a drone at a spot in the sky and have it hold on a target, you can do so much better with RTK. And then things like delivery, landing, all kinds of automation. And if you're doing mapping, now you're trying to translate things from the drone to the ground, and you're trying to position things like the announcement we did with Propeller. Their business is all flying drones in order to get datum off the construction site. So instead of the construction worker walking around with a pole, he flies a drone, and now he's got a grid of everything on the construction site. He can make in measurements. He can go onto his web browser and go between 2 points. He can estimate accurately how much material is in a location, all because the dimensions and the coordinates are correct for what's observed through the drone camera. It's super
Sure.
powerful.
Yes, it really is exciting to think about all the applications that exist there. So I ordered one of the new devices that can also do wing boots. We'll talk about that in a second. But from a network deployment standpoint, one of the things that was interesting to me about this was, is you're looking at the hexes, there's a fairly large geographic area within them. For the network to be able to have this accuracy that RTK can deliver, how many nodes do you necessarily need in one hex to be able to provide that super accurate location data?
So our hex size is set up so that one node can easily provide the best possible accuracy for the entire hex. So in theory, you really only need one node per regular sized hex in our grid. And a second node in there is good for redundancy because a lot of this work's pretty mission critical. So it's great to have the extra redundancy. But one node can provide coverage to every device in that hex with full accuracy and can frankly provide very good accuracy to all the adjacent hexes as well. Maybe not
Interesting.
perfect, but the coverage is pretty good, and there's no limit to the number of devices around that node that can use it. It's really a sensor. It's really helping GPS location accuracy by providing a signal that can take out all of the different errors that come between the satellite and the ground. And those include orbit errors, clock errors, and then all these ionospheric and tropospheric related errors, which we call kind of collectively space weather.
Okay. For the layman that's interested in how the technology works at a high level, can you just dive into the weeds a little bit? Because this is something that I was super interested in because it's such a large area and it's such a small sensor. I'm like, wow, it's incredible that this can provide such hyper accurate location data in this large footprint. So can you just, for the rest of us that are curious, explain at a high level how it all
Yeah,
works?
absolutely. So I think you remember the formula distance is equal to rate times time, right?
Yeah.
There's time of flight calculation. So that's how satellite navigation works. We have these satellites in deep space and they send a signal at a time. And that signal, in theory, travels at the speed of light to the Earth. And from you pick up that signal with your device and you measure the time you got it and you look at the change in time and you know where that satellite is from the satellite ephemeris and you get at what's called a pseudo range. And if I pick up 3 satellites, now I have 3 pseudo ranges to the satellites. I know where the satellites are. I know my pseudo range to those satellites, and so I can now know where I am. So that's a basic trilateration process. The problem is this assumption that the signal travels at the speed of light is kind of corrupted by the ionosphere and troposphere, solar activity, space weather. That causes a variable delay. So that time delay isn't the full story. So I need to compensate for variations in that delay. Those delays are changing kind of location to location and second to second. And that's where that reference station, which is the fixed station, comes in. So by having a fixed station in the same vicinity, now I'm able to see the delays that it sees and subtract them out from the original measurement. And that's how I get this massive increase in precision, is by that compensation for those variable delays that aren't quite following the speed of light when the signal goes from the satellite to the Earth.
Interesting. So you can abstract or sort of reduce all of the concerns that you have with the space weather contamination, if you will. I know one of the other things with GPS, for example, if you're in a city, the signal bouncing off the glass windows within buildings can create problems. You're able to mitigate that as well, I assume, with RTK?
Yeah, it's a combination of RTK plus typically sensor fusion does a really good job of mitigating that. And that's something like the GEO-PULSE device does a really brilliant job of. So by combining a couple techniques together, you're able to fully mitigate that. There's also one of the other really unique things about GeoDNet, and part of what is leading to its growing demand side is there's new signals from the satellites that are particularly good at mitigating multipath. And those are on the GPS constellation, the L5 signal, and on the Galileo constellation, the E5A signal, and on the Beidou constellation, the B2A signal. And these are really just recently started broadcasting these signals. They have a wider bandwidth, which makes them much less susceptible to multipath. Why GeoDNet plays such a key role in those is almost all the competitive older networks that were put out by governments as well as Web 2 competitors really, I don't think any other network besides GeoDNet, and I believe this is a true statement, has 100% coverage of those signals. So every one of GeoDNet stations has these modernized signals that do so well in mitigating these errors that you just talked about. And if you don't have the signal in the reference station, then you can't really take advantage of that signal in these differential positioning techniques. You have to have, that's why we always say you want a very good clear sky installation of the GeoDNet station, because we want to get a superset of all the satellites. In the US, that's typically 35 to 39 satellites. In Europe and places like Australia, it can be upwards of 50. We want the base station to have every satellite and every signal so that no matter what satellites and signals the device on the ground sees, because you're not going to be able to see them all when you're down on the ground, blocked by a building, blocked by trees, but you're just going to be able to see some. We want to make sure that the network has every single reference signal for the device in the field so that it can take advantage of the fixed positioning of the GeoDNet device in order to get the maximum impact in terms of accuracy improvement for the device that's being used, whether it's your phone, whether it's a drone, whether it's a robot, whatever it is. It's not going to see as many as the reference stations. The reference station wants to be the superset of all the satellites and all the signals. And GeoDNet does a really exceptional job of that by the fact that all the stations are uniform, they're all triple band, they're all quad constellations. So it's a bit in the weeds, I know, but it's just to say that there are actually performance advantages of GeoDNet relative to other networks. Not only do we have more stations than any other network, we also are the only fully modernized network out there.
And I think it's so exciting and it's an important thing to understand because it can be a little bit complex sometimes with, how does all this fit together? And so I appreciate you giving us such a thorough explanation because I've been, mulling over all the documentation to catch up to speed as quickly as I can.
Know. It is a little dense and it does tend to give a bit of a headache to think about all this stuff, but there is a real rhyme and a reason to the way that the network has been, why it's popular, why it's important to sort of deploy it the way we say it. It's just, it really creates a commercial impact, but it's not obvious why, but there's a real reason to it.
Yeah, well, and the demand side revenue that's kicking in is certainly a proof point of that. You talked a little bit about the new hardware. I'm excited. I think we talked about this before we got on the podcast here, but I did order my new GeoDNet WingBits device. Can you talk about what led to that partnership, kind of the thought process that went into this new device that's different from the one that exists today, and just sort of unpack that a little bit for us?
Yeah, so I think that the thing that really led to the WingBits GeoDNet partnership was they were looking at a way to have a device that's easier to install, more professionally controlled, has better location accuracy, and their current fleet of ADS-B tracking devices are all kind of DIY, and DIY has been popular in ADS-B, but it's not that easy to set up. You got to break out the Raspberry Pi, buy these different parts, and it's pretty uncontrolled. And the entire commercial aviation industry depends on this hobbyist network. And as air traffic increases and drones enter into the airspace, there's a need for a more controlled, better quality network. And so a real professional device made a lot of sense. At the same time, the topography or the topology, geometry of as you will, of the WingBits network is quite similar to GeoDNet. So there's this obvious synergy. Well, if a person's going to deploy and we both kind of need that coverage, why not have a device that can do both? Save, a person needing to get up on their roof 2 times, getting good installations 2 times. You can do it 1 time and mine both of the projects at the same time. So that, I think, was an impetus to kick off the relationship. And we also were ready to embark in a process of kind of a new generation of hardware design. We wanted to have a device that had more upgradability features, could be deployed more easily in a kind of off-grid configuration with less dependence on more flexibility in ways to backhaul data. And so we wanted to build a kind of all-in-one type of device as well. And so we put our heads together and came up with a completely new device It is a all-in-one, so you don't have with the traditional GeoDNet device, you have an antenna on the roof and then a little box in your home. This is the WingBits device. I'll hold it up here. Super excited. These things are on track to start delivering in January as promised. I've got one fully running now at my house as a test device. There are several more test devices around, but it's all in one. So you're really just plugging in a cable to it, or for power and wired Ethernet, or just power and then using Wi-Fi. It's also got this sort of capability where there are two expansion bays, and one of those expansion bays is the ADS-B, but it could be used for something else in the future. Who knows? But certainly that's the way they're configured when they're shipped out. And then a second expansion bay that could be used for another project or for 4G. And this expansion bay is this mini PCIe standard. So there's little cards that just plug in, and these can be, they're going to, of course, come completely configured, ready to go for WingBits and GeoDNet mining. Should something come up and they need to be changed, you just unscrew these 4 little screws and you can take it out and change it in the field very easily. So that upgradability, we think, is a really nice feature, and certainly the option to be able to, in the future, add a 4G card so you can do a real off-grid deployment. I think it's a really, really novel new design, really top quality finish. The hardware, I think, level of quality, it's aluminum base, fully weatherproof, sealed. The ADS-B antenna plugs right in the top. We're going to ship one ready to go with the unit. But then if a person already has an ADS-B set up with an antenna that's remoted, you can also alternatively plug the ADS-B into one of these SMAs. So it's got 2 additional SMAs on board. We've even thought of, there's other type of networks that WingBits is interested in tracking, other type of vehicle things. So there's a second SMA that could potentially be used for that. And then you've got your main power connector. So it's a really all-in-one device. And I think that's going to really help people who are deploying, maybe not at their own property, but are deploying at other people's properties, make that a much easier process.
Yeah. I wanted to circle back on one thing that you said, which is if someone already has an antenna set up, would they be able to, like on a roof, for example, connect it to the device maybe inside, or they could, because it's fully weatherproof, you could set that unit up on a roof, for example, because it can handle the weather?
Yeah, so you can set it up on the roof directly. If they have an ADS-B antenna, say they were working with WingBits before and they already have the antenna on the roof, that's right. They can connect into that. We recommend this auxiliary port for that, but they can just take their existing ADS-B cable, plug it in, and be going. So either way.
Perfect. This is helpful for me because my dad is in my house. There's already 2 units in the hex, but my dad's house, about 10 minutes down the road, does not. So I'm going to be jumping on his roof when my unit comes, so I can go install that. I just wanted to know what I need to be doing for that, which is great.
It's got the same 5/8 inch thread that the traditional GeoDNet antenna has. So it's, if you wanted to just swap out, if you had an existing unit that you said, hey, look, I just want to use the same location, but I want to mine WingBits and GeoDNet at the same time, you could actually reuse the same mounting rod that you had before and replace it. Or we're also, of course, shipping a mounting rod with the unit, so you could just toss on a second mounting rod and put it on another spot on the roof. Either way.
Very cool. That's amazing. What are the connectivity? You mentioned that there'll be a 4G chip that you could essentially install later down the road. Otherwise, it's powered by Ethernet. Is that correct?
It's a standard RJ45 Ethernet. The cable actually has a barrel, 12-volt barrel plug for power, and then a regular RJ45 for Ethernet. It also supports 2.4 and 5 gigahertz Wi-Fi. 5 gigahertz Wi-Fi is a new thing for us. Previously, everything was just 2.4. So you've got those 3 core connectivity options, and then an option, these 4G mini PCIe cards. So this mini PCIe form factor that we're using, it's actually pretty well adopted, and there are lots of 4G mini PCIe cards that are out there. And so you'll be able to buy one of those and plug that in and add a SIM card and have a 4G backhaul. And that's something that later in Q1 we'll introduce, like a little guide on how to do that. Those things, you can buy them off a number of different websites, typically like $50 to $70 for a 4G mini PCIe card, and install it and up and running for 4G backhaul.
Yeah, the 4G backhaul for people doing, either deployments that are out with limited connectivity options is a really great thing. If you were deploying it at a house with relatively decent Wi-Fi, for example, do you recommend that people connect via Ethernet, or is the Wi-Fi sufficient for this?
It's going to depend on the situation. If the Wi-Fi signal strength is good enough, you can do it that way. We would prefer people to deploy it with wired Ethernet. I think the weakest link in the entire GeoDNet network tends to be Wi-Fi. So
Okay.
Wi-Fi is good and works quite well, and it's obviously the backbone of what we're doing. But I think wired Ethernet just has a slight edge on reliability. People, have too many people on the Wi-Fi network and the performance goes down a little bit. Sometimes people change the SSID and forget to, then you got to go around and change the SSID on all the devices. Wired Ethernet just is kind of pretty bulletproof.
That's good to know. I think everybody that's excited about doing the deployments, it's always nice to share what's the best strategy or the best way to get this done so you don't have to think about it. It just works in the future. So that's really
Yeah.
helpful. I appreciate that. In addition to this new device you have, I know you also have a GEO-PULSE unit that's able to be pre-ordered right now. Is that something you can talk about as well?
Yeah. So this is GEO-PULSE. We've been doing lots of testing. A couple of customers have been helping us do testing. We have another batch of prototypes going to come out. We're going to try to fulfill. We did a campaign with Hotspotty and we raffled off some devices. We're going to try to get those out pretty soon and then start shipping the orders in mid to late January. This device is the world's most accurate car navigation device. The core thing that we're going after is people who are driving daily for a living. GPS on your phone works most of the time, but sometimes it puts you on the road. It doesn't do well in the downtown urban environments you mentioned. It doesn't do well in tunnels. So this device combining the RTK with sensor fusion from an IMU in there, it's just really robust navigating device. And so if you have an older car that doesn't have an in-dash GPS, this is a quick way to get super high accuracy performance. Even if you have a car with in-dash GPS, if your business, your daily life really depends on accurate navigation, you're going to see an improvement. When you put this device in, you're going to be able to, right out of the box on Android, replace all the GPS on all the apps. So if you're using Google Maps, whatever, you'll be able to get the high accuracy GPS. We'll have that capability for iOS probably later in Q1. We have to go through MFI certification to get that. We're also going to have our own standalone GeoDNet app that'll be called Quest. And the idea is that this app will encourage people to use the GeoDNet RTK network, get experienced with high accuracy location, and in the process earn a few tokens. So there's going to be some token rewards for mapping RTK coverage. There's also a partnership between GeoDNet and IoTex where they're looking to use the device to do work with their ZK verification system and provide a new level of kind of anonymized proof of location. And so that will also provide some rewards that should be meaningful to people who get it up. And we're planning other quests. We're planning, and the works are already talking with a couple other groups that want to leverage having a fleet of accurate location data from vehicles that could also supplement and provide other quests. So the goal is to make it fun. The goal is to make this sort of every time you drive, you may get notified, hey, I got some new tokens. So that's the ultimate goal. But with the questing side of it, but primarily this is going to be for people in Web 2 for a lot of different applications. This is the lowest cost RTK ready car navigation device ever created. So it's a breakthrough just from the point of view of car navigation.
Yeah. One of the other opportunities or use cases from my standpoint that seems really interesting is an alternative or the potential to replace something like a LoJack in the case where vehicles have been stolen. I know I've always had LoJacks installed in my car for those cases. Sounds like this is something that you could leverage for building a better version of that potentially. Is that
That is
am I thinking the right way?
yes, you are. And probably over time, we'll do one with a built-in battery. This first one doesn't have a built-in battery. There are a lot of applications in what we call yard management systems and in geofencing. So geofencing is an area where location accuracy really matters. Normally, you can't make too small a geofence. Most of these fleet monitoring systems have pretty wide geofences as the minimum size that you can geofence because they know GPS isn't that accurate, especially around buildings and things. So they don't want customers setting a geofence where there's going to be a lot of false detections, like where it's going to be ambiguous as to whether the device is inside the geofence or not. So tight geofencing is a very useful application for RTK in general, and getting into that fleet asset monitoring type of marketplace yard management systems is something that we already have some partners who are very excited about the GEO-PULSE as a product in that category.
Interesting. Okay, I'm excited to hear about what transpires in the future there. There's a lot of opportunity, it sounds like. Speaking of the project a little bit more generally outside of just the, product specific developments, You guys have really developed a governance structure for the network that's evolved over time. Can you talk about that evolution a little bit, sort of the importance of governance within GeoNet, and just for people that are interested in getting involved in capacities other than hardware deployments, what that might actually look like?
Yeah, so we have a website, vote.geodnet.com. That is our governance platform. And it's based really around these location NFTs, which is what a person earns when they set up a station in a hex. And they're the first station to really achieve performance that's adequate for truly professional usage of the network. That kind of is the governance unit. And then we take staked and also locked tokens and convert them to that unit. So those are the kind of parties that have rights and governance in GeoDNet. When we started, we did governance by listening to the Discord and feeling our way through it. And I think a lot of projects are successful that way. I think it's a good way to start. But over time, you want to have a more formalized mechanism that can be more of a, I think, quantified weighing machine as to what the network wants to do. And I think that it's important, and especially when it comes to tokenomics changes or anything that in any way focus kind of affects the rewards. I think it's really important to take those things through a formal vote. And so that's why we developed it. I don't want to be the one deciding those things. I want the network to decide. So, and this most recent GIP that's up right now regarding how the super hexes work. I mean, to be clear, that proposal as written was 100% developed by the community. It's a super thoughtful, it's going to be a big win for us in terms of making sure that when super hexes are filled, they're filled with a node that we can absolutely deliver the quality level that we need for customers to use. So I'm really appreciative of it. And we tried to improve it. And then we talked about it and we realized that actually the proposal that was created was really pretty perfect. And so we just basically put it up for vote, and that's in process right now.
That's awesome. You got to love the power of decentralized governance. And I do appreciate that you've thought through creating a process that isn't just Discord discourse and evaluating that, because it can become, cumbersome. It's just, I hate Discord personally. So I appreciate the thoughtfulness there.
Indeed.
So outside of the governance things, I know that you've also developed a multi-chain future for GeoDNet. You're now on Solana via Wormhole. What was the thought behind going multi-chain?
Yeah, it's to be where other projects are so that we can maximize the utility of GeoDNet within the DePIN ecosystem. So I do think composability is a very real thing, and there are real use cases for composability. We have a couple examples already in our ecosystem with Wingbits, also with Rover, that's doing HD mapping type of work. And if we want those transactions to be smooth and facilitate easy interaction between them, you need to be on the same chain. You burn GOD to use GeoDNet, right? That's really the fundamental mechanism of how the network works. You buy back and burn. If a person's treasury is all on Solana, and how are they going to, we're going to ask them to go through a wormhole to use our network. It's super inconvenient for other Web3 projects to be bridging in order to use the protocol. Yeah, there are ways around it, but the closer and more real time we can make these token exchanges work, the more powerful the whole blockchain architecture becomes. So we need to be on chains where other customers and projects are. That's number one. Number two, we're really excited about bringing GEODNET to mobile phone applications. First thing will be this Quest application. That involves an extra piece of hardware, but we're hard at work at using GeoDNet, especially on Android devices, without any extra hardware. And so the Solana's leaning into dApps. They're leaning into the Saga and now the Seeker coming out. We think that it's really bold and it may not work, but we want to do our part to try to make a true crypto native ecosystem exist on mobile devices. I think if it were to work and over the next 3 to 5 years can happen, it's an incredible gift to humanity, because the actual mechanization, if you compare the mechanization of the App Store compared to the broader internet, it's really fucked. I don't know any other way to put it, but I can create a website. I can put what I want on the website. I can register my domain in the DNS, and I'm published. With the App Store, you hear story after story after story, plus the toll booth that they put in the way is also criminal. So the whole thing is a total mafia. It's totally fucked. And I will do anything I will work on any project that has a chance with Web3 to break that. And that's why we're really fired up to try to support the Solana mobile team, bring something unique to the phone, bring GeoDNet first to that phone, and hopefully that can enable some new experiences that drive more and more people to buy that phone and use it.
Yeah. Well, I was going to say, tell me how you really feel about these app stores, but no, it is so true. If anybody's actually published an app, and I have gone through the Android, Google
Oh,
Play
it's
Store and App Store, it is, to your point, it is fucked. It's terrible process. It's just the whole thing is a joke. And then of course, when you start introducing anything crypto related, that just becomes a red flag in and of itself. So yeah, it's turtles
I
all the way
mean,
down with problems.
it's just, yeah, just imagine if the broader internet were set up that way. Imagine if every time you wanted to create a website, you had to go to some arbitrary third party that had potentially very competitive interests in mind. I mean, think about the number of different things that basically start off as an app that then just get absorbed into the platform. How do you think the app developer feels about that? I mean, it's just totally, it's fraught with unfair competition, with random gatekeepers, with toll booths. It's really bad. It's
Yeah.
really bad.
Is there anything you talked about Seeker? Is there anything unique with the phone itself that GeoDNet will be able to, I guess, create that's not necessarily going to be true with like a regular Android or a potential Apple device in the future?
Well, I think that we've tested it. So there are variations in GPS chips from phone to phone. And what we like to see, and is true now on the majority of modern smartphones, is a dual band L1, L5 GNSS engine, which is there on the Saga and the Seeker. But we also like to see all the raw data coming out of that chip, which is generally made available through the Google SDK. So Google has this thing called, I think it's called Sensors or whatever their API is, but there's GNSS raw data available, which is the actual raw satellite measurements. And we've checked that on the Saga, and we've also worked with the Solana team to make sure all the signals that we need will be there on the Seeker. That's true on a lot of Android devices, but not all of them.
Mm.
Some devices do kind of restrict some of the signals that come out, even though that there's an open Google API to present those to app developers. Some of the phone baseband silicon does put some restrictions on it. So it's in that category that's going to be super friendly to RTK work.
Okay, that's great to hear. I did want to circle back on one thing that you were talking about with this sort of multi-chain future as you're supporting applications that are within different ecosystems. You're on Solana. I assume that there's like an IoTeX integration. You mentioned Wingbits. Are there other chains outside of Solana and IoTeX that you're going to be supporting
We're
either
still
right
on
now?
have good support for Polygon and the ERC20 based tokens, and we think that's a important ecosystem to support. There are definitely some new projects that are coming up in DePIN that have picked that ecosystem, and so we think it's important. We don't want to be prescriptive in how you use GeoNet. We just want to be a utility for a high accuracy localization that any dApp can use.
Okay, I love it. I think that's a great plan. What else is next for GeoNest? You guys certainly have your hands full with these new hardware devices that are coming out, all the business side, governance. There's a
Yeah.
lot going on, but what else is coming ahead for folks we haven't got a chance to cover yet?
Yeah, I think that you're going to see us to push more and more into robotics and drones and do more and more services built on top of GeoNet for that. We have in the very near term, we're going to be at CES in Las Vegas with a pretty awesome booth and a lot of customers there. There's going to be some cool new announcements. We see that show as really the most important show for us in the Web 2 space because it's a gateway to all the applications, automotive guys, even the farming guys come there. Believe it or not, John Deere does a big thing there, equipment makers from all over the world. It's a great place and it covers all the kind of ecosystems that are relevant to GeoDNet. So look for us at CES in Las Vegas. We got our hands full with that, just getting all the prep work done. And then, as you said, getting these products shipping.
All right. Well, if you're able to, feel free to put my order at the top of the shipping list. We'll be really excited for that. No, I'm just joking. But Mike, where can folks stay up to date with everything going on with GeoDNet? You have is Twitter the best place,
Yeah, I
Discord,
think
our
that
favorite chat channel.
Yeah, I think Discord is good if you want to get into the weeds, definitely, and really understand and be able to talk to people. Discord's the best. If you want to just stay up on the project, I recommend X. We everything is always there. And then if you subscribe to our YouTube channel, we're working super hard to create video content. We do a lot of interviews with customers and with people in the ecosystem. I'm going to be trying to do even more of that in 2025. We've grown our YouTube channel now to almost 19,000 subscribers. So
Wow.
we're putting a lot of effort into it. It's the only channel we have that works for Web 2 and Web 3. So X, Discord, great to reach Web 3. Our Web 2 community does not do X. LinkedIn is a good way to communicate with Web 2. It's a not super fun platform in my opinion, and it definitely doesn't do anything for Web 3. So YouTube is the only place where we see we can get traction with both at the same time. And that's pretty nice for us because we're always trying to speak to both markets at the same time. And it's like trying to repeat everything, do everything twice is a lot of extra work. So that's why we're focused so hard on our YouTube channel.
Yeah. Well, now you've got your podcast studio set up, so you can dial those recordings up even more, I assume. And it's cool you're actually
Right.
talking to customers within the network so you can highlight the use cases. That's pretty awesome to see because not a lot of projects really get to go in depth with the demand side of their market.
The customers love GeoDNet, so it's not too hard to convince them to talk about it. Some big customers, as you can imagine, don't want to talk about anything, and they just have absolutely individual engineers and product managers within organizations just have no ability to communicate outside their organization, and that is a fact for some of the really big companies. But smaller players and people who are especially in robotics and drones, I think they're leaning into this whole Web3 thing. They like it, happy to chat, and it is really cool. And even guys in survey and construction we found are pretty in farming are pretty open to talk about it because it's a big breakthrough. It's a big deal to have the accessibility and the coverage that GeoDNet has, and they want to share their experience, and it's fun. Yeah, I think it's really helpful.
Yeah. Well, we'll definitely link all that below so people can go check out the YouTube channel, X, Discord, if that's something that's more up their alley, but we'll have all of it available for folks. Well, gosh, Mike, I'm really excited. This has been a great conversation. Like I said, I ask a lot of just general people in the space, what are you excited about in DePIN? And your name is always thrown out there as someone that's doing it right between the demand side customers, what you're solving with the supply. Like there's just a lot of excitement around what you're doing and the traction speaks for itself. So I'm really glad we got a chance to chat about it, get to push the narrative forward a little bit. I'm excited to be a customer starting in January. And we just want to thank you for coming on to chat.
Yeah, thank you so much, Tyler. We're super excited. The community is the heart of the product. So we want to be out there and supporting the community any way we can and really appreciate you taking the time to make quality content for the community.
Absolutely. We like doing our part. Well, thanks again, Mike. We'll wrap it up here for everybody. We'll have all of that linked down below with respect to the different channels. We'll also have a link to the website so you can go grab a hardware device. And if you want to pick one up, you should definitely do it because this is a project we're supporting. I can assure you that. But with that being said, we will wrap it up here. Thanks everybody for tuning in, and we will see you on the next one. Thanks so much.
GeoDNet. Mind the sky.